Next slide. All right. So special thanks to our event sponsor, MCG. I'm now going to turn it over to Miriam Murby. Welcome, Miriam.
Thank you so much. All right, let me just share a quick screen here. All right, you should be able to, hopefully. Are you seeing a slide that says case management? Are you seeing kind of
Yes.
mountains?
Yeah.
Okay, good deal. Because it looks a little different for me. Okay, clinical reasoning and artificial intelligence. Okay, I have just a few minutes that I just want to share a little bit with you. For those of you who may not be familiar with MCG Health, we develop evidence-based guidance. I am one of the senior clinical integration analysts at MCG Health. I am a registered nurse by background, have a whole host of nursing experience, including the director of case management a few years ago. And I want to share with you, you're talking about artificial intelligence. I want to share with you a little bit about MCG, artificial intelligence, and clinical reasoning. So, like I mentioned, we're at that crux of evidence-based guidance and technology for across the spectrum with providers, with payers, with government organizations, all about providing consistent and defensible clinical decisions with improving outcomes and operational efficiency. And when we talk about artificial intelligence in clinical reasoning within artificial intelligence, the most important question is not simply whether the technology is fast, um, and if it's efficient. The most important question is whether it's clinically trustworthy. And at MCG, that trust starts with us as we author our guidelines that are available. And because we write those guidelines and we maintain them, we're not asking a generic large language model to interpret that clinical content on its own. We're applying an artificial intelligence framework that is built on the original intent, structure, and logic of the guidelines themselves. And this is what we call MCG synapse, and it's what allows us to serve as a true source of truth for reasoning over our clinical guidelines. So, talking about artificial intelligence, talking about clinical reasoning and MCG health, and all of that combined together, we call that MCG synapse. Okay. And one of the biggest strengths of MCG synapse is the clinical enrichments that go along with it. And it's these enrichments that are reflected in years of clinician led editorial judgment that's built into how Synapse reasons. So the system is not relying on only a keyword or recognition with these broad artificial intelligence interpretation. It's reasoning with added clinical context, intended indication logic, and the nuances that you as clinicians identify every day when you evaluate patient information. That's what MCG Synapse includes. And it's a gold standard of that intersection between evidence-based guidelines and artificial intelligence. And you can tell I kind of like to talk with my hands here. But just telling you a little bit more about the clinical reasoning called MCG Synapse, okay? I mentioned the enrichments that are a part of this clinical reasoning. Another key strength is the real world validation that is available. And it's that MCG Synapse is not only evaluated against synthetic examples or ideal test cases, it's evaluated against de identified real world encounters. And that matters. So, when you think about artificial intelligence and you're talking about the questions related to artificial intelligence and applications that you're thinking about, that is important to you because you don't deal with the simplified cases, you deal with real world situations. And that is what is important so that as we are going through and we're doing this real world validation, it's real cases so that it reflects what matters to you in the field, that we're building it into there. The other key component is continuous refinement. So, clinical reasoning with artificial intelligence, that is not something that can be developed in a vacuum. It is not a one and done type thing. It requires ongoing feedback, and we have a whole team of data scientists, physicians, informaticists that work together to evaluate the performance, that continuing strength. So, all of these things that I am talking about, and all of the different things that you see on the slide here, when you're evaluating for artificial intelligence products or artificial intelligence in general, these are the things that you want to be considering and asking questions about. Ultimately, MCG is it's artificial intelligence, MCG synapse, that is authored with guideline intent, clinical enrichments, and real-world validation and continuous refinement. There were lots of other things on that slide, but those are the key things that I focus on within my role at MCG. And it's not simply that we just use artificial intelligence. It's that combination that allows us to deliver the clinical reasoning that is rooted in trust, and it's powered by evidence, and it's strengthened by clinical integrity. So I give you this information to take forward related to MCG, but also when you're considering clinical reasoning and artificial intelligence, keep these things in the back of your mind and ask the questions of whoever it is that's related to artificial intelligence. Ask those questions. Do you have the evidence? Is it just efficiency and all those sorts of things? So I want to thank you all for just giving me a few minutes of your time today. We hope you enjoy, we at MCG hope you enjoy the rest of the session. And Evelyn, I'm going to turn it back to you.
Thank you, Miriam. Special thanks and appreciation to Miriam, again, the Senior Clinical Integration Analyst at MCG Health. So thank you. MCG has generously agreed to sponsor this event for you, our attendees. Awesome. So now we're going to go ahead and turn it over shortly to Dr. Chang. So, a little bio for our guest speaker. Dr. Chang, Alan Chan, is a physician and clinical informaticist with a passion for transformative potential of artificial intelligence in healthcare. After earning an undergraduate degree in electrical engineering from Brown University, he received his medical degree from UMass Chan Medical School and completed his internal medicine internship and residency at Mass General Hospital. Dr. Chan practiced for over a decade as a primary care internist while holding leadership roles in undergraduate and graduate medical education, care transformation, and clinician wellness. His work addressing clinician burnout sparked a deep interest in the potential of AI to improve healthcare delivery. I think we all know a little bit about burnout in healthcare, efficiency, and clinician experience. He currently serves as the Associate Chief Clinical Informatics Officer for Artificial Intelligence at UMass Memorial Health, where he leads initiatives in AI governance, policy development, evaluation, and implementation across the health system, with a particular passion for advancing AI literacy and responsible adoption. Dr. Chan continues to practice clinically while helping UMass Memorial Health to integrate emerging technologies safely, thoughtfully, and effectively into patient care. Welcome, Dr. Alan Chan.
Great, thanks. So, in some ways, it's unfortunate that you have to have your videos turned off because it helps me to feel like I can engage more effectively if you have your videos on. But I can understand for the purposes of this that videos off may be more appropriate. Um, so I've entitled this talk AI in Healthcare, What Care Managers Should Know, but really I think of this more as AI in Healthcare, what healthcare providers, what healthcare clinicians, anyone in healthcare, what should you know about AI? And I actually think Miriam's introduction was great because for those of you that may be relatively new to AI, I think everything Miriam talked about sounds really exciting and appealing, but there were also lots of phrases in there where you may not exactly know what that means or what is AI when it comes to reasoning, what is a large language model. So I actually really like to have these talks start from the very basics of what AI is, and I think that can really help inform your ability to then meaningfully assess different products or different solutions that people may be presenting to you. And I will say that if you have questions, it's a smaller crowd. I love engagement, as I mentioned earlier. So feel free to kind of react or respond and throw questions into the either the chat or the question and answer functionality. So I'm sorry for the long bio. I do a little bit of consulting work for an AI healthcare company on the side. And so the objective is essentially to cover some basic concepts around artificial intelligence to give you some familiarity with what some of the terminology is, because that can also be confusing. We're going to talk about what generative AI is specifically and what their strengths and weaknesses are, and then we'll talk about some ways in which AI can be applied in today in healthcare, in case management, and in the near future as well. All right, so you know, do you need to understand how AI works? And I would say that you really have to understand at least some level of AI to really be able to meaningfully use it and to use it safely. I think a lot of us, right off the bat, are on the right-hand side of this sort of flow diagram where we're thinking about different tools, we want to apply them, but without a basic understanding of how AI actually works, we don't really understand how it can go wrong. And I think that's really critical. So I am going to take us all the way to the beginning for a moment here because I think a lot of you may be coming from different levels of background and work our way up to the right. So to start at the very beginning, what is artificial intelligence? I think some of you have seen these kind of stacked diagrams before, but artificial intelligence, although it's been really hyped up lately, really has been around for many, many decades. It's some sort of information system or computer system that can perform a task that we typically associate with humans. Now, if you really think about that definition, like if you think about very simple technology like a calculator, right? Would you say that that's AI? I think people can debate whether that's AI or not. But before, the past few years where people are talking about chatbots and all those sorts of things, there were lots of different things that your computer could do. Maybe not super effectively, but your computer could certainly follow basic instructions and do tasks. And arguably, some of those basic functions are artificial intelligence. Sort of as we became more advanced, and these are subsets of each other. So machine learning is a certain subset or a certain type of artificial intelligence where these are systems that are learning without being explicitly told how to behave. So in contrast with traditional artificial intelligence systems where a coder, a human would sit down and write a bunch of code, like if this, then do that. In these situations, this is how I want you to behave. Essentially, the computer system's confined to behave exactly as the human has laid out. It only, quote, knows whatever the human has told it to know. There was a new branch of artificial intelligence about 2 decades ago that started to flourish called machine learning. And really, this contrasts the historical kind of intelligence where humans transferred our knowledge to computer systems in the sense that we actually had these systems learn on their own. And there are two subtypes, and it doesn't really matter that there are two subtypes, but I just want you to have heard about these, something called unsupervised and supervised forms of machine learning. And I hope you don't mind, but I take a lot of liberties with making analogies. And I think about, I think also just like how children learn, right? I think a lot of times we think about education as being a formal system, but you have young children at the ages of 1 or 2 that can speak English because they grew up in an environment where they hear a lot of English. They have not formally learned grammar, yet they are typically pretty grammatically correct, right? That's not explicitly taught, but it's learned simply from exposure to a volume of data, right? Just hearing English being spoken all around them. So what does that look like from a machine learning perspective, and how does it differ between these two types? Again, high level concepts, right? I can never keep straight in my mind what's an alligator and what's a crocodile. So here on the left are a mixture of pictures of both alligators and crocodiles. In an unsupervised learning, machine learning technique, you essentially say to the computer, hey, I'm going to upload tons and tons of pictures. I'm not going to define for you, the fact that there are alligators or crocodiles. I just want you to look at all these pictures and tell me if there's certain ways that you want to group them together. Okay. So if this machine is able to effectively process this, at the end of the day, unsupervised learning, unsupervised meaning you're not telling it, well, this is what an alligator looks like, this is what a crocodile looks like. You're just saying, hey, here's a bunch of data. Tell me if you think there are certain groupings or classifications that naturally seem to fit together. In unsupervised learning, it can process all these pictures and say at the end of the day, okay, I think there are two groups of things here. And one group may happen to correspond with your idea of crocodiles, and one group may happen to correspond with your group of alligators. But again, it doesn't necessarily know what an alligator or crocodile is. So, I'm trying to go from broad analogies like pictures to, let's say, in healthcare, right? Let's say you have a bunch of patients that all have hyperglycemia and pretend we didn't know about type 1 versus type 2 diabetes. If you fed a lot of data about these patients with hyperglycemia into an unsupervised learning model, presumably on the other side, it can come out and say, you know what? I think there are kind of two different types of these patients that have high sugars. I don't know conceptually what type 1 or type 2 diabetes are, but if we start to investigate, we realize that, okay, actually, it's identified that there's a certain type of patients who are insulin dependent that may require insulin and treatment at a younger age than this second group that in our minds are type 2 diabetics, but the model is identified as distinct from type 1 diabetes. I'm going to a little bit of detail about predictive models here because I think there's a lot of room for predictive models in case management, but just bear with me for a second because I think it will become pertinent more later. But that's unsupervised learning versus supervised learning. You're still giving this machine a lot of data, but this time you are labeling all the training, all the data that you're sending into the system. So in this case, I'm not just sending in a whole mix of unlabeled pictures. I'm sending in pictures, and every picture I'm labeling accurately and correctly, whether that's an alligator or that's a crocodile. So that's why it's called supervised. And the difference here is that in these models, their job is not to tell you are there different groups. Their job is to say, okay, you've given me a bunch of pictures of crocodiles and a bunch of pictures of alligators. You didn't tell me what to look for, but having seen enough of these, if you give me a brand new picture that you don't label as an alligator or a crocodile, my job is to tell you whether I think that's an alligator or a crocodile. Okay. So I know this sounds like maybe it's not that different from unsupervised learning, but it is different in the way it approaches things. It's not trying to group, it's actually trying to make a prediction based on lots of information that's already seen before. Okay, so you can start to imagine where there may be health applications of predictive models like this. I want to make a few points here, and I'm going to take lots of sort of side roads on this journey here. Is that at the end of the day, if you have data, you can make predictions. And a really critical point is that good data is necessary, but not sufficient for good predictions. And I think there's this common saying in computer science, garbage in, garbage out, meaning if you have lots of data, let's say the alligator and crocodile example, but if you have lots of blurry pictures of crocodiles and alligators, or you have some pictures that are just inappropriately labeled, right? If the quality of the data is not good, the model is not going to perform well. The predictions are not going to be accurate. So the starting point is really good data. But when I say it's not sufficient, you also have to be really thoughtful about the actual model you're developing. I'm not going to go into detail about these different models, but there are many, many different models you can use. But there has to be some good judgment around how that model is developed in order to process that good data so that it can make good predictions. But good data is really critical. Okay. And I started to make the point earlier that healthcare is one of those industries, one of those fields where we are just bursting with data, right? So if you think about all the different data points that we collect in medicine, that in theory should mean that if we are really sort of intentional about how we build our models, that we should be able to make good predictions. So that's something I want you to think about. Now, this I think is also a key idea where I think this term machine learning is a little bit misleading because it implies that these machines are constantly learning. And typically, at least in this day and age, that's not technically true. These machines go through a process of being trained, meaning processing all that data that they have, and then they're static, meaning they're sort of this black box. They've learned, and then you keep kind of having it perform by making new predictions. But unless someone intentionally goes back and says, okay, I want you to update sort of your knowledge to now more updated information, it's not typically actively updating itself. I know this sounds a little bit confusing, but I wouldn't really typically think of machine learning as machines that are constantly learning. I think of them more as a learned machine, meaning it's gone through an active learning and it's typically pretty static unless someone goes back and teaches it more. For those of you that have used ChatGPT or other chatbots, and I'll talk about that more in a second, I think, you can tell it information, but historically it does not retain that information well. These companies that built these models have learned, okay, we need to be more active about updating these models with information, but unless that's intentional, it's not happening automatically. Okay, I know that sounds like a subtle point, but basically, don't make the assumption that if you're using AI, that every time you interact with it, it's learning from your interaction and always getting smarter. Okay, because typically it's not. All right. So I'm going to keep going. We're going to dive deeper into more subsets. All right. So we talked about artificial intelligence, machine learning. Generative AI is a form of machine learning where the outputs are essentially things that we think of as being content that can be created. And specifically, if the content that's be created are words or language, that is something called the large language model. Okay. So large language models are a type of generative AI, and generative AI is a type of machine learning, and machine learning is a type of artificial intelligence. Large language models specifically have been designed to focus on producing human language. And it seems like it is creative. It is generating content. And that's where this term generative AI comes from. Generative AI doesn't have to be just text, it could be other things. It could be music, it could be um, other forms of output that's not necessarily text, but text output, language output. That's what a large language model focuses on. And I know this is a lot of acronyms, but I'm sure most of you have heard of these terms and LLMs. And what exactly does that mean, right? So I am going to focus on large language models to some degree because this really is where a lot of excitement has really been building up over the past several years. And you've heard, I'm sure, of many of these different models. There's many companies that are building large language models. They have different models that they provide. Like OpenAI is a company, and they produce a model called ChatGPT. Anthropic, which is getting more press lately, produces a model called Claude. And between these models, there's different forms of Claude, actually. There's some that are much more robust than others. There's different forms of ChatGPT. So it can get confusing quickly, but I just want you to keep in mind that a lot of times, kind of like Kleenex has been a sort of the branded version of Kleenex. I think people talk about ChatGPT because it was one of the first ones that was released. That is a large language model, and it's built as a chatbot, meaning an interaction you have back and forth as if you're chatting with an entity. Okay. So how do these things actually work? And this is where I get a little bit excited to say that it's actually helpful for you to have some understanding of what these systems are actually doing. I think some of you have heard that these large language models are a very good next word predictor. And I don't know if any of you have actually paused to think about what that actually means and what that actually looks like when it's producing output. So let me start with a basic example. Okay, so Evelyn has a question. Which is my favorite chatbot? I'll say that I'm mixed and I don't want to bias any of you, except that a lot of these right now are all what we call foundational models. They all actually work pretty well. There are certain ones that may be better in certain domains like coding, like Claude and ChatGPT. They have a different, or OpenAI as a product. But generally speaking, all of these function pretty similarly, but if you want to get into the weeds, I'd be happy to go deeper into these models with you. All right, so back into sort of how do they actually work? They're a very good next word predictor. Okay, so if I still refer to them as a black box, and I will for a while before we sort of unveil what's within the box, is that these boxes take an input, which is a string of text, meaning some words, and they produce a single output, which is one word. It's prediction for what the next word is. Okay. So if I put into this box, the dog wagged its blank, I think I can ask you, well, what is your prediction for what the next word here is, right? I think most of us would say the word tail is a reasonable next word predictor. And if you were to put this into a chatbot, it may very well do the same thing, but this is a very simplified version. So if you really believe what I just told you, that these things are just simply next word predictors, I think you may be really sort of in disbelief, right? Because for those of you that have interacted with these systems, like how is it possible that it can produce such sort of insightful, emotional, complex output if it's really only predicting one word at a time? And so I'm going to show you how it does that. And this is actually mind blowing that this is how it works. Just the other day, I had it write a poem for me, and this is the exact prompt I wrote to. This is Anthropic, so this is a version of Claude. Write me a poem about giving a talk on AI at a case manager's educational event. And so I won't read this whole poem, but if you skim it, there's three stanzas. There's an AABB rhyming pattern. The content actually feels shockingly relevant. Um, but how is the model producing this, right? How is it predicting this one word at a time, right? Because if it's predicting things only one word at a time, as it's predicting, it does not actually know what the rhyming word in the next sentence is, right? That to me is kind of mind blowing, but let's actually run through this, okay? So let's just look at the first stanza for a second. They came with their coffee and clipboards in hand, case managers ready to learn what they can. Okay. So when I start off with this system, I put in a prompt, write me a poem, I put it into the black box. It tries to make a prediction as to what it thinks the next most likely word is. Okay, now in this case, it's not like the dog wagged its tail where all of us would agree that tail should be the next word. In this case, it predicted the word they. Okay, and that's all that it did. It has no idea what the words after this will be. Okay, now the system starts all over again and essentially says, okay, now I'm going to tack on the word that I just predicted back to the prompt, meaning the input that I just saw. I'm going to feed that back into myself. The only difference now is that there's one more word in this prompt, right? Write me a poem, blah, 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 with the word they. Now I'm going to try to predict the next word. It predicts that the next word is came. Okay. It's all done. It doesn't know what the next word is. It starts all over again. And it says, okay, now I'm going to start all over. I'm going to put a new input, a new prompt. And this time it's this original instruction plus the words they came. And so on and so forth until it predicts one word at a time until it gets to a certain point where it says, I'm done predicting. Okay. Again, I just want you to digest what I've said for a second because again, this is really hard even for me, someone who's really interested in AI, to fathom, which is that as it's predicting, it literally does not know what the next word is until it feeds all its output back into itself and predicts the next word. It, when it produces the word hand, does not know that it's going to rhyme it with the word can until it gets the word they right before it and feeds all this back into itself. Okay? So truly, to me, this is what's so mind-blowing about these AI systems right now, how these current large language models function, is that this is what they do. They are a very, very good next word predictor. Okay. So essentially, it keeps predicting until it literally predicts essentially a word that means it's all done, and then it stops generating new output. So I'm going to start to throw in more words in here. This is how a context works, meaning, historically, when you've interacted with Google, you're doing a query, um, Google doesn't remember that you said, hey, tell me about George Washington's birthday, and it can do that. But if you said, was he ever married? Like Google has no ability to remember, in quotes, that you were talking about George Washington, right? You have to say, was George Washington married? The reason why large language models seem to recall conversations is because literally every time it's generating new output, it's feeding the entire conversation you've had with it back into itself repeatedly every time it's creating one more word of its response. So that's how it remembers. It's literally constantly feeding in the entirety of the entire conversation back into itself in order to predict that next word. That's very convenient for us when we're interacting with it because it recalls that whole conversation you've had, but as you can imagine, this is extremely computationally expensive, right? You've heard a lot about people saying, well, these systems take up so much bandwidth. They use a huge amount of water for cooling all these data centers. Why do these models take so much computational power? It's because of what I've just described to you. Every time it's producing a single word, it's looking at a huge amount of content and it's trying to predict a single word, and it's doing that every time it's predicting another word for you. Okay. So now we're going to unpack the black box a little bit. I'm going to try to go a little bit faster. So really within this black box of predicting a word, there really are sort of three different components, which is things that happen before the model tries to predict, things that happen within the model itself to try to predict, and then things that happen after the model's predicted something that the companies that make these models try to tweak so that the output is more palatable for us. So what is the pre-model? The pre-model meaning what do these models need before they can predict something? Well, they need a lot of information, okay? And essentially all the information that has been fed into these models, so in my simple analogy of the alligators and crocodiles, these models aren't just fed pictures of alligators and crocodiles. They're fed essentially any information that humanity has ever produced that's digital, right? So that includes essentially anything that's ever been on the internet, any image that's ever been digitized, any music that's ever existed. These companies like OpenAI have been voraciously gobbling all this information up so that they can feed it into their model. Okay. And the totality of the data that's fed into these models is called a corpus. That's just another term in case you hear it, a body of information. Okay. So this starts to explain some behaviors of these models that sometimes can be a bit perplexing, right? So a hallucination is when a large language model produces output that is not based in truth. Okay. Now, at the end of the day, what I've said to you is models are good at predicting information if they get good data, right? They don't actually know what truth is. They're not grounded in reality in any other way. They only see the data that they've been fed, right? So these models don't actually know when it's right or wrong. But because they're trying to predict the next most likely word, their output is always going to be very believable. Okay. And so my example, going back to my analogy of children, right, is that when I as a clinician think about hallucinations, I think pathology, right? I think psychosis. I think if someone's hallucinating, like something is wrong. But if you talk about sort of human development in childhood, right? If you're talking to a 4-year-old and you ask them, is Santa Claus real? That 4-year-old may say, yeah, of course Santa Claus is real, right? Are they hallucinating or are they simply reflecting data that they've been fed, right? So what is the data that a 4-year-old's been fed? Well, their parents both tell them that Santa Claus is real, right? They wake up Christmas Day, there are presents from Santa Claus, all their friends believe in Santa Claus. So in some way, you can think of that as their training data, right? They're not hallucinating Santa Claus. They don't know Santa Claus is not real. In their world, based on all the data they've seen, Santa Claus is real, right? So in the same way, models sometimes will say something that you may recognize as purely fictitious, absolutely untrue, but if the data the model's seen suggests that that's true, that's what it's going to say because it does not have any grounding in reality otherwise. Okay, so that's a hallucination. And at the end of the day, I think a lot of times people say, well, why can't you just teach a model to say, I don't know, right? You have to recall that these models don't reason and think like you and I do because they're next word predictors. In order for a large language model to actually say, I don't know, means that when you ask it a question, it has to first predict a word, I, and actually, sorry, I used the word token here. Token is a more technical term for a portion of a word, but think of tokens as words. And basically, it has to predict the word I, followed by the word don't, followed by the word no, right? So if you are asking these models to predict statistically the most likely output, it's not likely to predict the words I don't know in response to any query that you ask. Now, there are ways for us to try to work around this, but inherently, this is why these models don't tend to acknowledge gaps in knowledge. They still try to do their best to predict something that they think you want to hear. All right. So, because it's trying to produce statistically what it is most, let me rephrase, it's trying to predict the next word, and it's going to predict that next word based statistically on what it's seen. Okay. And this is where bias can also be baked in unintentionally. Okay. So, this is a sample prompt where I said, hey, create a picture of a physician sitting at a desk writing on a paper chart, and I want a picture of a framed unicorn in the background. And you may think I'm being a little bit silly because, wow, did a really good job creating a picture of a unicorn. It's seen lots of unicorns, right? What's interesting is that if you think about this, there's actually lots of inherent biases built into this image, right? This is a white male who happens to be pretty handsome, who's right-handed, and you can come up with other sort of biases, so to speak. And, are these inaccurate? Not necessarily, right? But we have to recognize that these are inherently potential biases because it's trying to represent a whole group of individuals, physicians, in a single image. And for whatever reason, its image of a physician is a handsome, white, young male. Okay. Now, what's interesting is that bias you may or may not recognize, right? But bias can be so baked into systems that these systems cannot overcome them. So here's an example where I said, now do the same thing, meaning I still want a picture of a physician with a unicorn in the background, but make the physician left-handed. And even in as advanced a system as we have today, the systems say, here's an image. Yeah, of course, here you go. Here's the left-handed individual, just as you requested. But as you can readily tell, this is still a right-handed individual, right? So you may say to yourself, how is it possible that something so capable still can't draw me a picture of someone writing with their left hand? And you have to remember that of all the images that these systems have seen, a huge majority of them are of right-handed individuals. So in some ways, its training data is so biased and so skewed toward right-handed individuals that even when you tell it to create something left-handed, it just literally has not seen enough to be able to overcome its severe bias towards right-handed individuals. Okay, so my point here really is that bias sometimes can be obvious, sometimes may not be obvious. Sometimes it can be overcome because I can say, hey, create me a picture of a female physician, right? But sometimes if there's so much bias in the data that these systems have seen, you can't even tell it to overcome the bias that it has. Okay. I'm not going to great detail here. So comment, the output is biased. So yeah, because again, the words hallucination, I think, has a negative connotation. A hallucination to me from a large language model is simply a reflection of the data that the model has seen. It oftentimes is problematic, right? And same with the word bias. Bias just means that there are inherent patterns in the data, and the models are going to reflect that data. And you, as a consumer of the output, have to always be aware that these models may be subject to whatever biases exist in the data itself. The models are not trying to be they're not trying to be malicious, right? They're simply predicting things based on data that they've seen. Okay, so yes, bias ultimately is a reflection of the input data or the training data. I'm not going to get into details of how the model itself works. So all that conversation was about the importance of the data that goes in and how that can lead to hallucinations and bias. The model itself gets slightly technical. What I'll say is that sometimes people have called these models essentially just parrots that predict the next word, and they don't really actually understand anything. What I would say to you is that they actually have a profound understanding of the human language and words. Their way of understanding things, though, are very different than the way you and I understand things. All the meaning of words are captured numerically in something called embeddings. Doesn't matter what embeddings are, but they're numerical representations of meaning. So that words that are similar, like alligator and crocodile, have similar numerical values, right? But alligator and chicken would have slightly more divergent numerical values. And there are many, many values that are tied to these words. Alligator and chair would have even more different values. But essentially, it has a very deep grasp of what words might mean in relation to others. That's what's captured in embeddings. And then parameters are how words may relate to one another. Okay, so things like tense, things like emotion, things like adjectives, right? How things relate to one another are captured in more numbers. Ultimately, everything is reflected by a number, but these numerical representations are extraordinarily complicated. And that's how it tries to predict the next word. And you might have seen or heard about things called neural networks. Again, how that works doesn't actually matter, but when I pass in an input, it's going through lots of numerical calculations that gets, in theory, deeper and deeper into different types of meaning and different levels of meaning until finally it spits out an output after complicated calculations that's a single word, and that's its prediction for what the next word is. Okay. But my point here is I don't think it's fair to say that these systems don't understand anything. They do understand, but their understanding is very different than your and my understanding.
Dr.
Okay.
Chang, I'm sorry to interrupt real quick. There
Yeah.
is a comment or question in the chat. I
Mhm.
don't know if you noticed that one.
The outcome bias by input, or the one from Lori, is that right?
Yeah.
Yeah, I think I commented on that already in the sense that it's the output reflects the input. So if there's bias in the input, there will be bias in the output. Okay. So if everything I said kind of makes sense to you, I really want to bring this home with another analogy. Like, how do large language models work? So pretend that I, as a human, want to walk from my house to my local library. Okay. How I do that is in my mind, I know where I want to go. I understand that maybe it's 4 blocks away, that, I have to cross a crosswalk. I kind of make up a plan and I start heading in that direction. And my analogy here is when I want to create a sentence or a thought, like I have an intention, right? I pick words to reflect a thought that I'm trying to convey to all of you. And so that's how I work as a human. How would a large language model, let's say you have a large language model bot that is standing where I'm standing and it's trying to get to my local library. What it's doing is essentially saying, okay, if I want to get to a library, let me first look at every other person who's ever tried to go to a library from where you are right now. That's the training data, right? Large language models have seen all the data on the internet. It's trying to make a prediction based on everything it's seen. So in my situation, if I'm trying to go to a library, it says, okay, of everyone else who's ever tried to go to a library from where you are right now, where do they if they were to take a single step in a direction, which step would they take? And maybe the output then is, okay, I'm going to take a step forward. Okay. I take a step forward, and as a large language model, I'm essentially done, but I say to myself, okay, let me start over. Taking that step is almost like generating a word, right? I've taken that step, I start over, I say, okay, now from where I am now, for anyone who's ever tried to go to a library, which direction would they step in next? And maybe my prediction is, okay, I'm gonna step one step to my left, and then I'm gonna start all over again. So from an outsider's perspective, if you're staring at a robot walking to the library, they're doing these calculations very quickly. So it seems like they have intent. It seems like they plan out their whole route. They get to the library. It seems like it's no different than a human getting there, except it's extraordinarily different because it literally is only planning one step ahead at a time. And frankly, when it gets to the library, it doesn't even necessarily know that it's a library. It asks itself, okay, for anyone else who's ever tried to go to a library from where I am right now, where should I go? What steps should I take? It says, oh, for everyone else who's tried to go to a library from here, they actually stop walking. So that must mean I'm there. Therefore, I'm going to stop walking. Okay. That's how large language models work. And again, externally, when you're chatting with one of these systems, it seems very human-like, but the way it's working is fundamentally different than the way you and I think. Okay. I'm running out of time, so I'm going to go much. I don't know if this is interesting or if this is too deep, but I just think it's really helpful as you think about how AI can be used. Explainability, let me talk about briefly. These models, you can ask them to explain themselves, but they don't actually have insight into how they work, right? They produce an output for you that sounds like an explanation, but they don't actually have insight into the calculations that they use to get to an output. So oftentimes the challenge with these models is you don't know exactly how it came to a certain conclusion. And that's where there can be danger, particularly in the healthcare space. Okay, so one sort of corollary to that is that sometimes the explainability is not a big problem because it can be readily verified by a human, right? If I pass this into an AI system, this is an X-ray, and it says, hey, there is a right upper lobe pneumonia. I can see that here. There's some white splotchiness. The model predicts that. I, as a radiologist, can look at this and say, yes, I agree with that. So the model is right. The problem is that as these models become more sophisticated, it starts to produce output that we cannot verify and that we don't know how to verify. So believe it or not, even though I've never been taught as a physician how you can determine race from chest imaging, there are now studies that have shown that if you feed X-rays and CT scans into AI systems, they can tell you what the race of that individual is. It doesn't mean that it's making it up. It means that there are signals within this chest X-ray that we as humans don't recognize. We don't know what they are, but the AI systems say, hey, this is an Asian individual, right? So now we're in this interesting situation where um, I don't actually, as a human, know how to verify this, right? The model may be very confident in its output, but do I trust its output if I have no way of actually knowing how it made that determination? Okay. So these are some of the risks of explainability and models. I'm going to skip over the post model portion, except to say that there's a good reason why when you're chatting with ChatGPT and you say, can you help me build a biological weapon? It says, oh, no, I'm not going to do that. It's because these companies that produce these models say, look, before you actually show any output, let's do some checks to make sure that you're not swearing, you're not behaving inappropriately. So the companies that produce them try to impose some sense of their values onto these models. And I won't go into detail here, but there are some funny and sort of sad examples of how, this is Google trying to make images artificially more diverse when in reality they just made these images historically inaccurate, right? They were injecting all these sort of diversification words into prompts that people would enter to make output more diverse, which is not appropriate. So bottom line is that over time, all those things that I've mentioned to you are problematic, and to some degree, they probably always will be problematic, but we can mitigate them and try to reduce some of those problems. But we also always need to be aware to be on the lookout for some of those issues that I've mentioned. All right. I'm going to spend a few minutes talking about agentic AI, and then I'm going to stop and then just engage in a conversation with you about how you think, based on everything I've said, and actually I'll have some diagrams of how we can use AI and how you already have been using AI. One thing that I think is very confusing is that many words around AI also involve the letters GEN, gen, right? So generative AI is what we talked about. It's AI that can create content. There's also this term artificial general intelligence, which is slightly different. It means sort of AI that can perform at or above human levels in all domains. This is sort of like the holy grail of what a lot of these companies are trying to do, essentially make an AI system that can do anything a human can do. And I think arguably we're not very far from this already, but this is a slightly different concept than generative AI. And then the real hot topic lately has been agentic AI, okay, which is different than just regular AI. And so I'm not going to read through this text, but I think the analogy I want you to have in mind is historically, or over the past few years, our interactions with AI have been through a chatbot, right? And I think of this kind of like if you're talking to a travel agent, right? Talking to a travel agent can be very helpful. It's kind of like a chatbot. It's an interaction. You ask a question, they give you an answer. They're very knowledgeable, so they can be very helpful, right? Now, an agent, though, differs from a typical chatbot in the sense that they are actually able to take action for you. They're not just gathering data for you, but they are actually specifically taking action. So, not just talking to a travel agent, but saying, hey, can you book me that trip to Disney with my family? Can you figure out where we're going to eat? I want you to make reservations. And I want you to help me figure out this whole Lightning Pass business that I don't really understand. So, really having it act on your behalf. And we really have been shifting now more from these typical chatbots that can simply provide information to agents, meaning AI systems that can be enabled to do work for you, right? Now, this becomes more risky because if they're doing work for you and there's not oversight, that means that they can take action that can be problematic or detrimental, right? Are you prepared to give an agent your credit card to make purchases on your behalf, for example, right? I would say most of us are not, but there are plenty of people out there that are actually enabling AI systems to do that sort of action taking. All right, this chart is just saying, and I think a lot of you know that the performance of these models is just continuously getting better and better. And there are many, many strengths of large language models. The major weaknesses, the data is really critical. It's not grounded in human experience or truth, and it is computationally expensive. But a lot of these issues, as I mentioned, can be mitigated. All right. My last comment, then I'm going to stop talking for a second. But one thing I really do want you to think about in healthcare particularly is that a lot of times we hold our gold standard of whether to use a tool against perfection, right? I think we talk about AI, we say, look, it's got these faults, it's got this problem, so we're not going to use it. And I think that's a very reasonable thing to consider. I think we also have to acknowledge that we as humans are imperfect. And so the challenge here is that our comparator for AI systems should not be perfection, but should really be versus human performance, right? And I think self-driving cars are a great example. There are tens of thousands of deaths from motor vehicle accidents secondary to human error in the US yearly. But every single time there's a single injury or death from a self-driving car, that makes it to the news, right? It doesn't mean that we should disregard that, but it means that the bar can feel very different. But when you normalize it to what our current state is, I think that's an important thing to keep in mind. All right. I'm going to stop talking for a second because we only have 6 minutes. What I'll say is that, as I look at some of the, and I'm a physician, right? So I think the truth is I have some insight into all the different tasks that you do. But I was trying to summarize even sort of one aspect of some of the things that you might do, for example, post-acute care disposition, the amount of work that you need to do for that. Like, how do you think about AI and how it can impact your job meaningfully? And so let me stop there for a second and just sort of take questions and I'm curious to take comments. So
Hi there. I'll ask a question.
sure.
Just looking at your post-acute disposition and hearing you talk about at one point rule-based programming, would you assign a rule-based programming to this problem or gener generative AI? Probably.
Gr-
So yeah,
Great,
just Yeah.
Great question. And I think that hits a key point that I didn't emphasize, which is that right now, everyone wants to offer an AI solution to everything, right? And I think as you're looking at, for example, this specific example, if you're checking criteria, right, for payment or for a particular disposition to a SNF, like, do you technically need generative AI involved with that, right? Like, if you have a discrete set of conditions that need to be met, um, you can use what we used to call like plain vanilla AI, right? Meaning just deterministic, sorry, that's a fancy word, but like if then statements, right? If this, then this, if this, then this, right? You don't necessarily need fancy large language model enabled AI. Where can large language model enabled AI be helpful? For example, if there's information that's not discretely captured, right? So, for example, if the vital signs are a discrete field that you can do a simple condition check on, right? If this, then that. But lots of data are contained in non-structured notes, right? Like there's lots of important information that can be gleaned from a note that may not be a simple field that you can check an if condition on. Those are things that may be amenable to large language model processing, right? If you were to feed in the entire hospital course and all the notes, the physical therapy notes, the occupational therapy notes, the respiratory therapy notes, and then say, hey, AI, can you summarize for me some aspects of risk for this patient in any particular domain, that's where that can be helpful. And you can start to imagine where that might be helpful even in this workflow.
Thanks. So it seems like some pieces might be amenable to a rule base, like check if it's a th inpatient times 3 days, or check if the PT recommends rehab. And then the rest is more not, I know, I don't want to say generative, but uses a large language model to look at the unstructured data and
Correct.
generate the response.
Yeah, I think the key is how many of you are using well integrated systems that can even make those simple determinations for you, right? Like, 3 days, right? Like that should be really simple, but that feels like it can be really hard. Like, are you manually literally like counting days? Like, what is your workflow for that like, right? Before we even talk about getting into the large language models, there are many things that we actually can and should, but have not yet accomplished just with basic AI. But I do want you to start thinking about, well, where then can we start to go with this technology now that we can really start to understand the chart much more meaningfully without having you literally dig through one note at a time, looking at various criteria, flipping through various Excel files or PDFs to try to figure out is this patient suitable for them, calling up a sniff to see if they have bed availability, right? Like, could that be automated in some way? And now you can have agents that can make phone calls that can actually literally talk to someone else and ask questions and report that back to you in a field, right? That sounds futuristic, but that technology actually all exists now. Actually, I see another question about driving up costs. I guess I would say that there's lots of promises that have been made around AI, and that AI implementation requires a lot of investments, right? I think the challenge, especially from my perspective, is what is the return on investment? Have we proven that they improve, at the end of the day, are they improving health outcomes, right? I think the interesting thing is we don't really have any definitive evidence that AI improves mortality or improves quality of life. Not yet, at least, right? Do I believe that ultimately we'll be able to show that? I do, but I think the analogy is, and this may be mind-blowing to some of you as well, EHRs have not been proven to improve healthcare, right? It doesn't mean that they haven't, but it means that it can be difficult to show. At some point, I think, right now there's a lot of investment. At some point, I think we will start to see more of the returns. I think the danger here, and I don't know if this is an undercurrent of your question to some degree as well, is well, what are the impacts on the workforce, right? If AI really is as good as everyone says it can be, like are organizations secretly using this just to be able to enable cost savings down the line? And I think that's a very complicated question. And the truth is, it's kind of hard to really see beyond a certain point. Lots of organizations will say, look, we just want to enable our teams to work better. We're all overwhelmed as is. We're simply trying to do a better job with the folks that we have. But I think your point is right that right now there are more costs and we're still waiting to really realize a lot of the benefits. Evelyn, I'm sorry that I ended up taking more time than I thought. We're at 7. I'm happy to stay on and continue chatting if folks have questions, or I don't know if you have a hard stop that we have to stop the session.
Yeah, I know we started a few minutes late. I don't know if anybody else has any other questions. I know you had other, yeah.
Hi, Dr. Chang. Thank you for your lecture. It was very interesting. It helped me a lot. I'm trying to fill in the blanks for myself. I'm really into critical thinking, and I'm been studying what the literature talks about as far as that. It recommends that humans, and this is the other thing, since I started like looking into AI, it's like there's another population out there now. I'm a human and you're an AI agent. And so it's kind of shocking in a way. And so in the literature, it talks to the fact that um, one of the challenges to humans is that they should become master critical thinkers to be challenging the information like that. We can't just, allow a machine to give us information, but have to be able to critically evaluate it. And so I'm a big advocate of that now. I don't know if you have any
Yeah,
thoughts on that. There's lots of
yeah.
articles on that. Yeah.
I would say that the critical thing right now, and this is often invoked in healthcare, but in many high risk industries, is human in the loop, meaning, as good as these systems
Yes.
are, we are not ready to say, okay, let's get rid of the case managers, let's get rid of the physicians, let's have AI take over. Now, what I will say is that there absolutely are specific tasks that all of us do where we can say, look, this I do it all day long. And frankly, it's somewhat tedious, and I don't know that this is really where my time is best spent. And I have no doubt as I look at some of these diagrams that you can imagine a million ways that's true. I think that's true for all of us. And so I think the question really is how can we use AI in a way that can help address some of those tasks that are a little bit more laborious, less value add, so that we can do the real value add. Now, I have lots of interesting thoughts about reasoning. Like, for a long time, for many years, like we still clearly as humans, it's crazy that I have to distinguish when I say we, that I'm referring to humans. We, I think, reason better than these systems do. The improvements that have been made to these systems, though, have really been mind-boggling. There are specific reasoning models, and I can go into exactly what that means, that actually can go through a thought process not dissimilar to what humans do to really try to problem solve and to actually um, share how it's going through that journey. And this is where the agents are actually doing a relatively good job. And so, will there come a point where, um, well, I'll just say that we can't ignore the fact that AI is getting better. I think all of us will have changes in the types of roles that we have. And we always have to be wary of sort of our role in all this, especially in healthcare, that we are still overseeing the final output, which is patient care.
Great. Well, thank you. That's an excellent answer. I appreciate your time. All
Yeah,
right,
thank you.
Evelyn, turning it over to you.
Thank you. It looks like Kaylee has a question for you, Dr. Chang, in the chat. She says, any specific insights of future use that you're excited about?
Yeah, I guess I'm going to take my really distant sort of um, vision down a notch, which is that it's easy to talk about how we can enable AI in all these different areas. Where I really just want to see true sort of improvement is like I want all of you, within a year from now to say, you know what, like compared to a year ago, my job is more meaningful, it's more satisfying because AI has enabled me to do less of this and more of that, right? And as a clinician, as a physician, it's like basic things like chart summarization, right? That would benefit all of you as well. Like I don't need to be, I don't want to ever have to go through chart review and click through note by note, reading paragraph by paragraph, trying to filter in and filter out all this meaningless information just to glean certain nuggets. Like that is a task that's perfectly suited for AI. But how many of you have access to a tool like that, right? ChatGPT can do that. You can upload it, a 40 megabyte document and have it summarize things for you. Why can't we do that yet routinely in healthcare? A lot of us are trying to do that, but I'm not even quite ready to proclaim this vision in the future of, okay, imagine where all of this is AI enabled. I just want to see in the near future use cases where all of us can say, I'm happier in my job. I'm doing a better job taking care of my patient because AI has allowed me to do X or Y.
So, Dr. Chang, interesting. I'm actually going to a work meeting in Florida, and one whole day is related to AI and use of AI in our job and how we can use it, taking medical records and putting it into AI and having them spit that out, write our clinical impressions, all that is literally one whole day. And there's a group that's been working on that.
Yeah, what I'll say is
So
that, there's so many functions that you can do with a generic chat GPT, right? Like I know it's very tempting for all of us to say, hey, why don't I just upload this PDF to chat GPT? I think one thing that a lot of you are aware of that I'll just really emphasize is you have to be careful that anything you upload into a publicly available large language model like ChatGPT, in theory, that data then can be used by them to train, meaning it's leaked out. So you should only use large language models or chatbots that have been sanctioned by your enterprise, by your organization. We are still working on that. Many organizations use like Copilot, for example, the Microsoft product, or have agreements with OpenAI. So if your organization has a tool like that that can take in PHI and you know that they're okay with you uploading stuff, I would say absolutely you should be doing that because it doesn't make sense not to. I think, though, unfortunately, for many of us, we do not have yet access to a tool like that. So, as tempting as it is to just upload that document to your private, your personal ChatGPT account, you should not do that because that is problematic. So,
yeah, no, we use Copilot and it
yep.
is an organizational, like it is safe. You can do this. We can put our data there and it's the entire organization. There have been training. Some of them are like, you lost me. I don't know how this refers to my job, you know? And I think that's where they're coming down to the specific roles and how can you use it and what are the best prompts? And it's kind of an interesting way, you know? How can we have that time to do the other things we need to spend more time on
Yeah, absolutely. And I
than
think
reading 1,000 pages of medicals to figure out what's, the summary?
yes, I am hopeful that those days are soon going to be behind us. So I agree with you. And I think that the issue of how do you create the right prompts, what are the appropriate portions of any role that can be handled by AI, there's a lot of subjectivity, and I think a lot of this is to be determined. And I think part of the challenge is that the AI is constantly changing. It is getting better. And just when you feel like you're getting the hang of something, it feels like there's something brand new out there. So this has been head spinning. I think even for me, someone who is trying to stay on top of what's going on. It's like every week, every month, it's like, oh my gosh, I feel like I don't understand anything at all.
Yes, moving quickly for sure. Well,
Yeah.
thank you so much, Dr. Chang, and thank you to all the participants. I know we have Maureen, I think we have one last